Vanakkam, I am K. Sadish Kumar, working as an assistant professor in the Department of Automobile Engineering at Hindustan College of Engineering and Technology, Coimbatore. Today, we are going to see the tire friction between the road, which is one of the primary motto to design vehicle. As a tire, it has to give minimum friction with the road. There is multiple factors deciding the friction between the tire and the road. Here we are going to see a deeper analysis how the friction is generated in between the tire and the road. There are two primary mechanisms responsible for friction between the road surface and the tire, which is shown in the figure. And one is the surface adhesion arises from the intermolecular bonds between the rubber and the aggregate in the road surface. And the second one is the hysteresis. It is a loss due to energy when the tire part is going to contact with the road. In a wet condition, the frictional coefficient is less for adhesion, whereas it is more for hysteresis. Here you can see the contact length of tire with the various factors, that is vertical load, friction force and relative slip. As elements enter the tire contact patch, it is undeformed. As it is proceeds into the center of tire contact, deformation must occur for the tire to sustain frictional force. The deformation increases from the front to back so that the force developed by each element. At high braking levels, the rear extreme begin to slide on the surface and the braking force from the tire may begin to decrease. The graph clearly shows the braking coefficient decreases when the slip of the wheel is increased. Because of this mechanism, the brake force and slip are coexistent. From the above figure, it can be said that up to 20% both the peak and sliding coefficient is more. Under wet road a condition, that is the adhesive friction contribution is diminished, in overall coefficient is lower. The peak coefficient of friction establishes maximum braking force by tire road friction. At high slip, the coefficient diminishes, reaching its lowest value at 100% slip, that is full lock condition, which is denoted as μs. In braking condition, the μp value should be higher, but it is only theoretically possible. But in actual condition, while braking, the wheel is decelerated to achieve μp. But any disturbance in this condition will cause the wheel to decelerate, at which the slip is increased further until the wheel goes to lock. Only a brake release, that is our anti-lock braking mechanism, can return the wheel to operate the μp. There are some other elements involved affecting friction. The one is velocity. On dry roads, both peak and slide value decreases with the velocity. Under wet condition, even greater speed cannot improve the friction because of displacing water in the contact patch. When the speed and water film thickness is sufficient, the tire tread will be lifted from the road. The factor is called as hydroplaning. And inflation pressure. On dry roads, both the values are mildly affected. On wet surface, both the value will be increased. And last one, vertical load. Increasing vertical load normally reduces traction levels under both wet and dry conditions. Thank you.